My name is Sarah and I'm a climate scientist.
My name's Iain and I work for Sarah.
You will be my slave.
It's totally cooked.
It's Totally Cooked, the climate and weather podcast.
In this episode, I declare that we are going back in time to find out when and how global warming started, what global warming is, and what it's doing to our weather and climate.
Can we get a DeLorean?
No. Well, maybe. Okay, so I have built a time machine. Do you want it to be a DeLorean? Is that your time machine du jour?
Well, I just don't see how it could be anything else.
We're going back 250 years to 1776.
That sounds like a really ominous date.
American Revolution is raging.
Yep.
We are going to Great Britain, where a revolution of a different sort has been breaking out. For 10 points, Sarah, can you name that revolution?
Eunice Foot.
That's not the name of the revolution.
Oh, right. Oh, shit.
What's the name of the revolution that's been happening?
Oh, the Industrial Revolution.
Industrial Resolution.
I'm totally cooked.
Yes.
Yes, the Industrial Revolution. Is that the date that it started? I didn't actually know the specific.
I mean, if you look at 1750 is, in most climate science, that's like...
That is true.
Where the industrial age is sort of roughly calculated from.
We run our climate models from 1850, though, as a control. Don't go that far yet, Sarah.
Scientists, don't button on my script here. So the reason I chose 1776 is because that's when James Watt's steam engine starting to be widely used in commercial applications.
You have done your research.
I have done my research. I was about to say I've done my research instead of doing my job, but it's my job.
Research is your job.
Yeah, steam engines. The steam engine had been invented by someone else. I think a guy called Thomas Newcomen, but it's Watt's version of it is the one that becomes really popular, and it soon is powering factories, it's powering ships, it's powering railways when they're invented, and this transforms the whole world. Steam power transforms the world.
Yep.
How do we get steam power? How do you make steam power in 1776?
Can this be like Who Wants to Be a Millionaire and I get options? Or
you
do I
can
have
phone
to?
a friend.
I can phone a friend.
Or Radio National can phone you.
Maybe 2GB needs to phone me. No, I'm going to go with D. Coal.
It's D. Coal, yes.
What do I win?
You win a climate crisis.
Yay!
Congrats. And a career.
I don't laugh, I'll cry.
You made a whole career out of it.
This is true.
Almost as if it's in your interest.
It's not. I want coal to be gone.
Gone.
Gone skis.
Gone.
Gone.
Well, it is going. We're getting rid of it.
Not fast enough.
We've burnt a lot of it. We've sold a lot of it. There seems to be no downside.
Small footnote.
Small downside. Serious question, though, because I'm not a scientist. You're a scientist, right?
Apparently, yeah.
What is coal?
Coal is a fossil fuel. It's, as the ads have told us for a number of years now, it's a little black rock. It's technically not a rock. So how we use coal is a fossil fuel. We can burn it, and then that converts the energy within the coal into energy that we can use. So powering steam turbines or turning on lights.
I'm interested in what you're saying about how coal is and isn't a rock and where it comes from. Like how did coal get made?
So it's not like a rock like sandstone or a clay-based rock or slate. It's buried deep under the ground more often than not, and it needs time and heat and everything to pressurize, but it actually comes from organic or dead things.
This is my layman's understanding, or coal for dummies. It's like squashed trees.
Squashed trees, squashed animals, squashed dead ex-living things.
Dead living things. Yeah. Organic matter.
Organic matter,
Quotes,
that's
unquote.
correct. That's been squashed, pushed, pressurized deep in the ground, and it turns out that it stores a lot of energy that we can use. But the thing is, it's not just formed like, let's make some coal today. It takes hundreds of thousands, if not millions of years to reach that proper coal fossilized type state.
So can we call it renewable energy? Sort of.
Some geologists might think
long-term renewable energy.
No, I would not. Hard no. It is not renewable energy. And there's things that are used in other countries, not necessarily in Australia, but are close to coal. So peat, for example, which is used a lot in the Northern Hemisphere.
A major source of heating and energy in the Shetland Islands.
Yes, yep. I remember travelling to Ireland in my early 20s and they were throwing what looked like mud to me on the fire. And I was like, why are you putting that on your phone? It's peat. They use it that's a fire hazard.
Roofs or walls. It certainly was a building material in, I say certainly, I'm not a historian. Back in the day, medieval or Dark Ages.
Yeah,
Northern
right.
Europe, I think they built with it too.
Maybe too many houses burnt down.
So you said coal's a fossil fuel?
Yeah.
Like natural gas?
Natural gas is
petroleum
too. Yeah,
/
petroleum.
food oil.
Well, that's, Yeah.
What happens when you burn a coal?
It releases carbon into the atmosphere. And carbon, so that carbon that it's been storing for hundreds to thousands to millions of years is poof, gone in an instant up into the atmosphere.
Are carbon and carbon dioxide the same thing?
When in the way that we talk about carbon in climate science and weather change, we talk about carbon dioxide.
Carbon dioxide.
Yeah.
Right.
So there's also like carbon monoxide, which is what cars sometimes leak out of their tailpipes.
Okay.
But carbon dioxide in its chemical formulation is one carbon atom and two oxygen atoms.
Of course, your car wouldn't be leaking any carbon monoxide, would it?
No, I drive an electric vehicle and I'm smug about it.
So smart. What about carbon dioxide's different states? Like, when is it a gas? When is it?
When it's in the ground in a fossil fuel, coal, oil, gas isn't a solid, obviously.
When it's in the ground,
It's in the ground, it's solid.
It's a solid.
There. Yeah.
Yep.
So when you burn it, it releases it into a gas.
It also dissolves in water, right?
Yes, it does. It can make oceans and water more acidic because of once you put carbon into a water source, a reaction happens and acid is part of the end result of that reaction.
But let's focus on it as a gas, right?
Yeah.
So when it's a gas
Yep.
and it's in the atmosphere,
Yep.
how much of the atmosphere is carbon dioxide?
So I think currently we're at roughly 420 parts per million. So for every million little bits of the atmosphere you might have in your hand, if you can hold it in your hand, 420 of those parts will be carbon.
And so don't get me wrong here, folks, but like technically it's not that much.
It's a tiny, tiny fraction of what's in the atmosphere. That's correct.
I have some hard numbers here, which is that in May 2022, it was 421 parts per million,
Yep.
which is 0.042%.
Yep, that's right. Maybe slightly higher than that now, but
Probably now, 2 years
maybe
later.
0.00 whatever, 40.
43.
Yeah.
Pre-industrial levels
Yep.
were 280 parts per million.
Yep.
0.028%.
That's correct.
As a climate dummy, that both sounds like not that much overall and not that big an increase.
100%. So for anyone listening.
No, it's 0.042%.
That's, yeah.
Imagine if it was 100% carbon dioxide. We'd be in a bit
We'd be totally cooked. We'd be Venus. We'd be very
wow.
close to Venus.
Well,
yeah.
they do say that podcasts are from Mars.
Scientists are from Venus.
That's the old saying, the oldest one in the book.
How sexist is that, by the way, that book? Anyway.
Oh, gross. There's a book about that.
Men are from Mars, women are for Venus.
We've established the fact that, yes, carbon dioxide is a trace gas in the Earth's atmosphere.
Technically, there's not that much there.
Technically, there's not much there.
Yeah.
What little there was has gone up.
Yep.
But overall, not by that much.
No.
So why does it have such a major effect on our climate and weather?
Because it's not like other gases in the atmosphere.
What sort of gas is it?
It's one that, under the right conditions, which occur when you're like super high up in the atmosphere where the carbon sits, it traps heat in
Which
for
we
longer.
could describe as a
greenhouse effect or greenhouse gas.
A greenhouse gas. That's
Yes,
what I was
it's a
looking
greenhouse
for. It's
gas.
a greenhouse gas.
Do you think about a greenhouse where you...
What's a greenhouse? We're millennials and Gen Z. We live in apartments. We don't have gardens. We don't have greenhouses. What is a greenhouse?
I don't have a greenhouse because they're really hot. If you live in a cold climate and you might want to grow plants that grow in warmer climates, you could build yourself a greenhouse.
Okay.
And it's effectively a glass enclosure. The sunlight comes in, helps grow the plants, but then it's trapped, the heat's in.
Sunlight goes in through the windows.
Yeah.
And it makes it hotter in the greenhouse.
That's correct.
Because, the heat comes in from the sun, but it doesn't go back out again.
It does a bit, but slower. So what happens, I'm going to get all sciencey now.
I imagine that may happen sometimes in this podcast.
Yes.
And
I'm going to try and break it down as not like super science, Sarah.
Can you break it down like carbon dioxide in the atmosphere? Does that work? Does that work?
It does work. I'm trying to work out how it works, but it does work.
I digress. Please tell us.
What happens is the sun comes in, really short lengths or wavelengths we call them, so light's really close together.
Visible light?
Yes, some of it is visible light, some of it's not visible. It comes in as what we call a short wave radiation, right? So it's light and heat coming in from the sun. The waves, so think of waves at a beach that are really close together. We have those short waves coming in from the sun. Now that goes through the glass. It kind of hits the inside of the greenhouse, like the surface, whether it's the earth or the table that you might have in there or the plants themselves. It's absorbed and then it's re-sent back out as longer waves. So think of slower waves at a beach. And the glass will trap that in. So it'll let short waves in, but won't let those longer waves out. Or not as quickly, I should say.
Hangs around for longer.
Hangs around. That heat stays in the greenhouse for longer. So you can have your lovely tropical plants in your frigid cold climates.
Like tomatoes in the south of England.
That's correct. At any time of the year.
So this greenhouse gas, in this case carbon dioxide, has always been there. It's naturally occurring. And
there used to be more at some point.
There has been more, right? Yeah. When we had dinosaurs.
Dinosaurs, less plants,
And if there wasn't naturally occurring greenhouse gases and a naturally occurring greenhouse effect, what would the Earth look like, or what impact would that have on us?
We'd be much, much, much colder. I can't remember. Maybe is it 30 degrees colder?
I was doing a bit of reading about this in my research, and I think it's, it varies, but it would be maybe 18 degrees Celsius would be the average temperature. Sorry, minus 18 degrees.
Yeah, so that's just under 30 degrees cooler than what it is now.
Point is, we have been conditioned to kind of think about the greenhouse effect almost negatively because we're exacerbating it through...
So this used to be a tactic of climate deniers.
Please tell us more.
They were like, but we need the greenhouse effect. We need it to keep us warm. Without those greenhouse gases that are, by the way, a tiny fraction of the atmosphere, we would be cooler and we wouldn't be able to live. The greenhouse gases are our friend. They make Earth a good place to live.
Interesting.
And we do, I'm not going to lie, we do need a little bit in there to keep Earth at a comfortable temperature.
And this might lead us to talking about our friend, the carbon cycle.
Yes.
So greenhouse effect, normal, it's always been there and we need it.
Yeah.
Greenhouse gases have always been hanging around in smaller amounts than there are now and doing a good job of making sure we aren't frozen, because my understanding is that there's a natural flow of carbon between the atmosphere, the land, the oceans, sediment.
It's a cycle, right?
It moves
around. Yeah. And, yes, there has been carbon in the atmosphere, but it's been more or less stable for quite a while.
How long would you say?
Millions of years.
A million years or so, right?
Yeah. The new research comes out every day by saying how long it is, but we've got, a million, maybe even longer than that.
But based on what we were talking about just now with our percentages, human activity specifically since around 1750, Mr. Watt and his chums building trains have increased just trains, just trains have increased levels of carbon dioxide in the atmosphere by around 50%.
Yeah, yeah.
So, when we were talking about the 0.02 versus the 0.04, it doesn't sound like that much, but it's
That's
double.
The thing, though. We can't focus on the absolute value, the absolute amount, the total amount of carbon in the atmosphere. It's the fact that it's increased and it's really bloody potent. It's not so the atmosphere is mainly made up of nitrogen. Oxygen's only something like 23 to 25%.
But another greenhouse gas is methane.
Methane, yeah.
And it's increased by...
Oh, that's increased rapidly. Gosh.
150%.
150%, but it's measured in parts per billion.
Okay.
So it's an order of magnitude less when you in that measuring unit than carbon dioxide.
For those who are not aware, definitely human activity.
Yep.
What are the major sources of increased carbon dioxide?
Burning fossil fuels. 3-word answer.
Anything else? Like
that methane. Sorry, I was thinking mainly carbon. Yeah. So look, cows can release methane, and they do. It's really not as nearly as much though as what comes out of other sources.
And also like heavy industry.
Heavy industry,
which is also burning
clearing.
fossil fuels. It's just burning even like more amounts. Making steel, you've got to have like super high temperatures.
That's it, and you need more energy. Enter more carbon, more coal. You need more energy, and that releases carbon into the atmosphere.
And we gave a little shout out to the dinosaurs a minute ago. And so now, through our busy work in the last couple of 100 years, we now have CO2 levels in the atmosphere that are higher than they have been for around 3 million years.
So I thought it was roughly 1 million, but maybe...
No, like they were stable for about 1 million.
Yeah,
but they're now higher than they have been for...
Wow, that must be new science. I haven't read.
Or it's just wrong. It's probably... I mean, in many respects, folks, that's probably something we should be sure about before we put it on the internet.
Producer Zach
is getting the phone out.
Yeah, so let's say 1 million.
Well. So are you saying, Zach, that the climate scientist was right and the former football journalist who was on Wikipedia last week may have been wrong? What?
There's been times in paleo climate records, so like climate records from long ago, millions of years ago, that it has been higher.
Jurassic Park time.
Like 5 million years ago.
Well, actually not Jurassic Park because that was...
No, that was...
recently.
don't get me
Park
geology.
recently.
I'm not doing that shit.
Okay.
But no, we're millions of years. Maybe you don't want to go back that far
We've
yet.
probably, got bogged down, like the dinosaurs, like the coal, a little bit.
They died. They got buried.
And then they became
we
coal.
burnt them.
Right, fitting. We've gone round and round. But CO2 levels in the atmosphere, way higher than they have been for ages because of what we've been doing.
Yeah, correct.
Okay, agree?
Yep. Pass, yep.
And because of the greenhouse effect, these higher levels of CO2 in the atmosphere are making the world hotter.
Correct?
Yep. what would we describe this as?
The greenhouse effect.
Well, no, I was going to say this is global warming.
Climate change.
Anthropogenic climate change. Let's stop on that point, right? So anthropogenic climate change, global warming.
Let's go climate change. Global warming had a lot of shit flung at it.
What's the difference? And why was the shit flung?
The shit was flung because, again, let's go back to the skeptics. Let's go to the early 2000s. Back in our DeLorean or fridge or whatever we're traveling in today, they were like, oh, the climate isn't just warming, and maybe that's a good thing. And then there came like the climate hiatus where apparently the globe stopped warming for a brief period in time, but there was still climate change. So it used to be global warming, but it's kind of over time being rebranded climate change because in some places, very small amounts of places, how climate change manifests could be very different. So it's a change in climate because of greenhouse gases. That's largely almost everywhere. I'd actually argue everywhere is associated with warming, but then other effects might knock on from that too.
So climate change is kind of a caveat in nomenclature to cover the very, very small parts where it isn't warming.
Well, yeah. The warming, though, could induce other change, which might negate the warming. That's the thing. But everywhere is warming.
Everywhere is warming.
Yeah. But it's not just global warming.
Shall we talk about how much warming and how fast? I'll run these numbers by you. Let's see if they make sense to you. According to temperature analysis by NASA, the average global temperature on Earth has increased by at least 1.1 degrees Celsius, which is 1.9 degrees Fahrenheit for weirdos, since 1880. The majority of that warming has occurred since 1975.
That sounds all about right. And each decade has been warmer than the decade prior.
At a rate of roughly 0.15 to 0.2 degrees per decade. Cool?
So it's getting faster.
You concur?
I concur.
It's getting hotter, and it's getting hotter faster.
Correct.
If, and I quote, if current emission rates continue, we will surpass 2 degrees of warming above pre-industrial levels sometime between 2040 and 2070. Is that now out of date? Would you say sooner?
This is a really good question. So the globe is at 1.1 to 1.2 now.
Toasty.
Very toasty. The thing is, we could reach 2 degrees before then, but it wouldn't be solely due to climate change. It would be to climate change as well as like a supercharged El Nino as well as something else. But climate change would be a major factor in that, absolutely. We couldn't get there without climate change. It would likely be not the only influence.
And if we got there, is that like, oh, we've got there and we've gone back down again for a while?
Maybe.
We haven't got there yet, have we?
No, we haven't got there yet. It would be a year potentially at, 2 degrees.
What's our max so far?
So Australia's wrong by 1.5 as Australia. I think Australia will get to 2 before then. Well, what was it last year? 1.5?
Which is quite a lot.
Yeah. No, was it 1.5 last year globally?
You're the heatwaves climate scientist, Sarah.
No, it wasn't. It was 1.23. I can't remember. There's all these ones and points and...
But it changes up.
The change is ever increasing up. You may occasionally get a year that's slightly cooler than the one prior, but it will be very brief.
My point is that this level of warming, say 2 degrees above pre-industrial levels, has been described by the Intergovernmental Panel on Climate Change as dangerous.
It is dangerous. It's unprecedented. The rate is unprecedented as well.
And the actual temperature itself.
Yeah. Yes, correct.
Why is a warmer world dangerous to us?
Because we're not used to living in it is, I think, the main bottom line. All of our systems, if we're thinking about ecosystems, human systems, ourselves, our physiology, we don't know what to do with hotter temperatures, more frequent extreme events because of the hotter temperatures. We don't know everything about how the climate will respond to hotter temperatures. We know things like, heat waves will get worse. A warmer atmosphere can hold more moisture. So if we do have a rainfall event, it's likely to be more extreme. We know those things broadly, but how that might play out over Sydney versus Brisbane, for example, or Sydney versus New York, or, name your favourite city. We don't really know. We're getting there, but things are changing because of the fact it's much hotter than what it used to be. And that means mostly bad things for people and where they live.
And I suppose this isn't in our remit, but all those physical, climatic and weather processes and the challenges they'll have on our physiology and on our food production sources, on our drinking water, on our physical safety will of course have many, many knock-on effects on our cultural, political conflict norms.
Yeah. And that's, there are a lot of unknowns there. Like we know these impacts will be bad. We know that they'll have further reach than just, how we might feel it, for example, but what that all looks like, how we're going to react to that. Huge unknowns. Huge.
So I know we've had a lot of fun today.
Yep.
Because you and I are sickos who are kind of like too deep in this now to not have a fun time with it.
I've committed.
Right? But it is, serious and scary stuff.
Yep.
Right?
Yep.
You're scared?
Yeah. I have moments where I'm more than scared. I'm petrified.
And we are not here in your ears to depress you.
No. It is scary stuff, but it doesn't mean that you should give up and die.
Exactly. We as a species have been painfully slow to act on these issues, and more needs to be done. Mm-hmm. But some positive progress is being made.
At least now we recognise that climate change is a problem. When I started out my career, it was still like, oh no, you guys are lying. And, here's some cherry-picked data to prove it because we don't want to change our ways.
It's really strange to think it's that recent.
It's that recent. And there's been a lot of research done that shows it was just like the tobacco companies when it came out that smoking kills cancer. The likeness is uncanny. We've moved past that point now. Basically, I'd say more or less the world has realised that carbon's a very serious problem. There's, people are mentioning a lot of things, what they're doing. I think there's still quite a lot of greenwashing that's going up in government. But we know we need to reduce our emissions and people understand that. That's no longer debated. We know we need to reduce our emissions.
For those who don't know, what is greenwashing?
Oh, shit, I used another term. So greenwashing is when you come in saying, oh, yes, we know that the climate is changing. We're doing these steps seriously to fix it or to adapt to it or to just make things better overall in the climate crisis. And it's just a whole bunch of baloney. It's lip service.
They're like creative carbon accounting,
Yes, and some would argue that there's merit to that. It can be good to get processes going, right? So
better than nothing.
It's a good starting point.
What it shows is that even if there's not actually anything useful happening, it shows that they know it's politically and culturally unacceptable not to at least be saying you're doing something.
That's right. True. So I guess that's the first step.
That's a small step in the right direction.
Well, so think about it like carbon tax in Australia. Like, yes, that blew up. There was nowhere near the end fix, but it was a first step. Like, let's put a tax on carbon. Let's put a price on it and change people's behaviour. Because if the cost of living is going up around that, well, maybe people might reach for the solar panels more than their cheapest energy plan that's not so cheap anymore because it uses coal. The idea was to change behaviour and get people thinking about it. We all know that ended badly in Australia, but that was the whole point, and it would have led the way for other mechanisms to reduce carbon.
I would love to get into the carbon tax right now, but that is definitely going to be part of a future episode on Australia's and the world's political relationship with climate change, which will be juicy. Well, okay, let's think from a science lens.
Yeah.
What are some of the things happening in Australia and around the world that gives you hope that we are sort of on the right track now?
Net zero is in everyday vernacular. Now, whether or not net zero is going to be as good as we think it will be in terms of creating a better world, that's another conversation. Maybe we can get into that. But it's a conversation. Like 15 years ago, no one was talking about net zero. Everyone was like, yeah, we'll just sweep that under the rug for a bit longer. In Australia, well, we have a net zero target by 2050. Again, we can debate the numbers as to what's realistic and what's not. But there is a target now. 5 years ago, we didn't have that. The government is pushing for cheaper energy that's green to be more accessible for every Australian, to make electric vehicles more accessible, and just basically to help Australians change their ways, give them incentives to change their ways. There's now mandated that houses in certain climate zones need to have light-coloured roofs to help keep out the heat in summer and reduce the urban heat island effect. These are small changes, but they are changes, and they're all in the right direction.
Do you think if we become famous podcasters and we get offered free electric vehicles that we'll be allowed to take
them? I would totally take it. No, I'd rally for that.
You'd rally in it?
It's not like they're giving us Dodge 4x4.
You could call it the Net Zero Drive.
Can we advertise the podcast on the side?
We could have a climate rally where we rally around Australia in our electric vehicle, rallying support for the Net Zero Drive.
Duh, why can't we have free cars?
Call it the weather van.
Bringing Totally Cooked to a city near you.
And we have screenings of Twister and The Day After Tomorrow at drive-ins all over country Victoria.
There's another Twister coming out.
You don't get how much do you? We've just aged ourselves out.
We really have. We're done. We're totally cooked.
Okay, that's definitely the end.
Yeah, that has to be the end.
Thank you to Sarah. We now know that pumping lots of carbon dioxide and methane into the atmosphere is causing big problems.
So many.
It's you.
Oh, shit. How do we know? In the next episode, we're going to talk about the climate science.
We're going to talk about ice cores, satellite observations, and supercomputers.
And who were the first scientists to understand the greenhouse effect?
There was no and there. Who predicted the problems caused by burning fossil fuels?
And how has our scientific understanding of climate and weather improved?
For the answers to those questions and plenty more, join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.